Hey guys, good morning. Can you please confirm, am I audible?
Yes, sir.
Good morning.
So yesterday we completed file integrity monitoring, and also we completed HDS HAPS. Today, and also we started application security. In the application security, we discussed about what is SDLC lifecycle and what is secure SDLC lifecycle. In secure SDLC lifecycle, what is our roles and responsibilities? What exactly we will take each and every phase of the respective software development lifecycle. So coming back, today topic is cryptography. So cryptography, basically, this concept is existing from long back. So cryptography general meaning is secure way of communication. So secure way of communication, how is it possible? Through encryption. So that process, entire process, we can call it as a cryptography in simple way. So in simple way, how we can say cryptography. So the secure way of communication, because we are discussing about application security. So the secure way of web communication using computer algorithms and also using mathematical calculation. So that is called cryptography. The secure way of web security or web communication using computer algorithms or mathematical calculations is called as cryptography. Examples of cryptography: encryption. Second one is decryption. So cryptography will use ciphers also. So cipher is nothing but it's a bit or size, that is called cipher basically. So examples of cryptography is encryption or decryption. Now, how we can provide a secure web communication through encryption or decryption? So we can provide key or password so that communication will happen in the secure way. That entire process is called as encryption or cryptography part. Now, there are two different types of cryptography technologies we have. Types of cryptography. Types of cryptography. Meaning is two, indirectly three. Symmetric. Second one, asymmetric. Third one is hybrid. So symmetric cryptography, asymmetric cryptography, hybrid cryptography. This is one of the favorite topic for the interview point of view. What is symmetric? What is asymmetric? And also what is hybrid? Hybrid is not that much, but symmetric versus asymmetric. Okay. Before going to this one, basically this cryptography existing from long back, not only now. Example, you can consider in olden days. So when you say olden days, maybe 5th century or 6th century or 18th century or 19th century, when respect to kings, they are ruling our kingdom. Okay. Example, consider as a Vijayanagara Samraj. So Vijayanagara Samraj versus Kakatiya. In between Kakatiya Samraj and also Vijayanagara Samraj or Vijayanagara Kingdom or Kakatiya Kingdom, if they want to communicate, what is the communication channel in olden days? Whether any telecommunication or GSLV or PSLV, all these are existing in olden days?
Yes, sir.
Whether it is existing in olden days?
No, sir.
No. You know how the
No.
communications happen in the kingdom? One king to another king. One king
By
to
the-
another king. Yeah, how the communication will happen that particular time in olden days? Through pigeons or maybe through, okay, so minister or servant. These people normally, they will make one letter and they will send it through person or maybe through pigeons. So this is the way how the communication will happen, right? Am I right or wrong?
Yes, sir.
Yeah.
Yes,
In
sir.
case, maybe example consider one of the Kakatiya king sent a message through person to Vijayanagara king. That person can open the letter. Can he see the data or not?
Yeah.
He will see the data. Now, whatever confidential data will be there, whether it will be leaked out or not, data exfiltration will be happen or not. Yes or no?
Yes. Yes, sir.
Yeah.
Yes, sir. It will happen.
Yeah, it will happen. So to eliminate that one, they will use couple of logic using mathematical calculation or maybe coding part, encoding and decoding part. So maybe example, how they used to do in the olden days. So they used to do this particular messaging in the so logical way of example a equals to 1, b equals to 2, c equals to 3 and so on, z equals to how much? A equals to 1, b equals to 2, c equal to 3 and so on, z equals to how much? 26. We have 26 letters, right? Yeah. And so on 26. Now, if you want to write high, then how we can write in the letter format? In the letter format, what is the H letter number? So eighth letter and I number
9, sir. 9.
9. So 89 they will give. But whether even though he's okay, so person is opening the letter, if he can see 89, whether he will understand or not. He will not understand. It's like a numbering format. Otherwise, one more example, A equals to B, C equals to D, E equals to F, and so on. Then finally, Z equals to how much it will come? A equals to B, B equals to C, C equals to D, D equals to E, E equals to F,
Yeah.
Z equals to A will come. Now, how we can write example high? How we can write high now? IJ. If I'm sending IJ, whether, okay, so even though whoever is reading the respective letter in between two kingdoms, they are sending a message, whether he will understand or not? He will not understand anything, right?
Yes, sir.
Yeah, only this coding and decoding will happen in between two kings only. How to open the message and what to read and how to read. That coding and logical thinking knows about only, okay, so kings basically. And even though whoever is sending or taking the letter and traversing from source to destination, they can't read it. So that's what I'm saying. This particular cryptography existing from long back. Now coming back to here, so that process also called as a cryptography. Now we can discuss about symmetric and asymmetric differences. So I'll put the left hand side is symmetric, right hand side is asymmetric. So symmetric general meaning is same, okay, or same pattern. That is called symmetric, right? Now, what is symmetric key definition? If same key used for both encryption and decryption is called as symmetric cryptography. If same key used for both encryption and decryption is called as symmetric cryptography. Okay, so now what is asymmetric? Opposite to this one? Opposite to this one is asymmetric. Two keys. Two keys used for both encryption and decryption is called as asymmetric. So asymmetric general meaning is different. Different keys used for both encryption and decryption is called asymmetric cryptography. Now practical example of symmetric cryptography. Can you give any practical example? Technical and personal oriented as well. technical and personal oriented as well.
Technical, sir.
Yeah, on the technical side, you can see yesterday we were discussing about disk encryption or database encryption. So disk encryption and database encryption will fall under symmetric because same key we can use for both encryption and decryption. So that is called symmetric. So disk encryption or OS encryption and database encryption will fall under symmetric. So in our day-to-day life, we have the home. If you want to lock our door, so door lock, we can use two different keys or same key we can use for door locking.
Same key, sir.
Yeah, same key. So same key we can use for locking as well as unlocking. So that one also will fall under symmetric in our day-to-day life. Now here example of the asymmetric side is any website access, RDP access, VPN access. Okay. So mail access, sending the mails and receiving the mails. All these will fall under, okay, so symmetric wise. Now, what is symmetric key functionality or features it will do? It will provide only confidentiality, but it will not provide anything, nothing but privacy of the data. But on the other hand, asymmetric will provide confidentiality, integrity, authenticity, non-repudiation, and finally encryption. So how it will provide, I'll explain later. Confidentiality, integrity, authenticity, non-repudiation, and encryption. So these things will be provided by asymmetric. But symmetric will provide only confidentiality. Which one is better out of these two now? Which one is better out of these two? Symmetric is better or asymmetric is better?
Asymmetric is better.
Asymmetric is better because it is providing more information as compared to symmetric side. Okay, now third point. For n number of keys, by the by, two pair of keys or two keys means what here? Two keys used for both encryption and decryption. So for encryption decryption, what are the two keys will maintain? Already we discussed part of domain keys.
Yeah, public key and private
Private
key.
key and public key.
Public key and private key. That's right. Yeah. Now coming back to here. So for n number of keys, formula equals to n into n minus 1 by 2. Okay, that is the formula. So example now, if we need 100 keys. Okay, if you want to extend the 100 keys, so what is the number of keys will be exchanged as per symmetric side? So instead of n, you can put 100. 100 into 100 minus 1 by 2. How much it will come? 50 into 99. So 100 into 100 minus 1 by 2. So 50 into 99, 4,950. Those many keys will be exchanged for the, so 100 keys if you want to exchange, 100 number of keys. On the right hand side, asymmetric side, for n number of keys, formula equals to 2n. Now you can tell me, so if you want to exchange the 100, then what is the formula will come? So 2 into 100, how many here? 200 keys.
200.
What about on the symmetric side? 4,950.
950.
Yeah. So which is using more number of keys? Symmetric or asymmetric?
Symmetric.
Yeah, symmetric is more number of keys. That is the next point. So it will use more number of keys or out of band key exchange. Meaning here more number of keys or large number of keys. So what about here? It is less number of keys per exchange. Now, which one is faster, symmetric or asymmetric?
Symmetric is faster.
Yeah, symmetric is faster because same key we are using for encryption, decryption, and asymmetric is slower. So these are the definition. So at the time of the interview, don't forget first 2 points. These 2 points are very, very important. Okay, even you missed out these two also, no problem. But first 2 are you have to remember compulsory. Now coming back to 6th point, I will put example algorithms. Example algorithms. On the symmetric side, we have RC4, RC5, 2 fish, blowfish, Mars, DES, triple DES or 3DS, AES, 3 AES. So these are the examples algorithm from the symmetric side. So out of all these, already couple of things are legacy or outdated. Those ones are up to here. Legacy or outdated. Legacy or outdated meaning here we should not use that one. Already these keys are outdated one. So which attack we discussed for this type of weak hashing algorithms? We discussed couple of attacks.
Sweet 30, sir.
Sweet 32, that's right. Sweet 32 attack we discussed. Okay, so if you are using weak ciphers, attacker can hack our systems. Example Sweet 32. So we should not use this one. What is strongest cryptography algorithms we have to use right now? AES or 3 AES. AES full form is Advanced
Encryption start.
Encryption Standard, and 3 AES is 3 is a version number and Advanced Encryption Standard, same. And DES full form is the Data Encryption Standard. If you want to use any symmetric cryptography algorithm, which one we have to use? Either AES or 3 AES. Latest symmetric cryptography algorithms. It's one of the favorite interview question, guys. Day before yesterday interview question, this one, this topic. Now coming back to here, asymmetric side example algorithms are. So already we discussed this topic also. Example algorithms are, we have RSA, Rivast, Shamir, and Adelman. So these are all the first algorithm. Second algorithm is DSA, digital signature algorithm. So third one is DH, Diffie-Hellman. Next one is Elgamal. Elgamal is a scientist name. Even Diffie-Hellman also scientist name. So Diffie-Hellman and also Elgamal is scientist name. So whatever algorithm they invented, directly they put their name itself. So Diffie-Hellman and Elgamal is a scientist name. Next one ECC, elliptical curve cryptography. So next one is knapsack. So these are all the asymmetric side. So we can use any of the asymmetric one because it will be the strong encryption and strong ciphers. So all these are asymmetric and symmetric side algorithms. So on the asymmetric side, we can use any of these algorithms. On symmetric side, we can use only AES and 3 AES. I'll put in the green color. So this also I'll put in the green color. And coming back to here, RSA, it has a bit number of 512, 1024, 2048, and 4096. Latest bit size of the RSA is 4096. In the similar way, all the algorithms bit number also same as it is. Even we can use in the certificates we can use combinations also. When you say combination, AES plus Diffie-Hellman, 3AS plus RSA plus Diffie-Hellman, ECC plus Diffie-Hellman plus AES, these combinations also possible. We can use that one also because both are strong encrypted algorithms or strong ciphers it will use. Okay, so that's all about symmetric versus asymmetric cryptography algorithm side. What is the next one? Hybrid cryptography. So hybrid cryptography is also called a PKI, public key infrastructure. Public infrastructure. Here now, I will explain about keys first. So there are two different types of keys. So one is public, second one is private. So public key is a shareable. This is also called shareable key. And private is also called a secret key. We should not say this one. We can keep with ourselves. Public is shareable and private is secret key. So now in the hybrid cryptography, what is hybrid general meaning? What is hybrid fruit or hybrid flower? What is hybrid general meaning? Combination of mixer is called as hybrid, right? Now this one, how we can define? Combination of both. Combination of both symmetric cryptography and asymmetric cryptography. So that is called hybrid. So symmetric plus asymmetric cryptography is called as hybrid cryptography. Understood? Now, 90% of the organizations we can use combination of symmetric plus asymmetrics only. And where we can see these cryptography algorithms in the SSL TLS certificate. Now I'm going to show about one of the SSL TLS certificate. So right now I'm opening docs.google.com. So this is an application or a website. So this is a lock symbol. Lock symbol, it will represent HTTPS, including encryption with a secure way of web communication. Okay, I'm clicking on this one. Now you can see connection is secure. Can you see my screen?
Yes, sir.
Yeah, click on this connection is secure. And you can see now connection is secure. Certificate is valid. Click on this one. Now you can see common name or domain name or fully qualified domain name is google.com. So that means this is a legitimate website. It's not a fake website or it's not a defaced website. If it is a really attacker website, we can't see google.com. Okay, so we can see some other name. Okay, so now issued by GTS. So GTS is nothing but Google Trust Services. So Google company is purchased the certificate from Google Trust Services LLC and certificate authority. So this is wherever Google is purchased the certificate. So that authority name is called a certificate authority. That place they purchase this certificate. And so when the certificate is issued on October 23rd, and when it is expiry or going to expire, it is on January 15th. Okay, till that time, if any attacker is trying to do hacking on the Google website, They can't do that. Why? Because already this certificate is providing the integrity, encryption, authenticity, and secure way of web communication as well. So very less chances are there from the attacker can do man in the middle attack or session hijacking or WASP top 10 category of the attacks. Okay, so this is the public key. So whenever you are accessing now Google Docs, this public key is shareable one. This public is shared by now docs.google.com to us, and we can open our docs.google using this key. So in such a way, encrypted channel from that I will explain, give me some time. SHA-256, this is the hashing algorithm and details of the certificate. So it's a root certificate and google.com is a website, and version number of the certificate is a 3, serial number of the certificate, and certificate signature algorithm is SHA-256 with RSA. So which hashing algorithm it is using? SHA-256. This hashing algorithm, it will provide integrity. And RSA is encryption. It's a Rivast, Shamir, and Adelman. RSA is symmetric or asymmetric?
Symmetric.
RSA.
Symmetric.
Symmetric, sir.
Asymmetric. RSA is asymmetric. Okay. Issued by GTS, Global Trust Services, and where the certificate is deployed in the USA, and validity. So validity is provided, and the public key, all these are certificate side. Okay. So if you are using this certificate, attacker can't hack our websites or application. Even though he is hacking, we have less chances are there to take unauthorized access or sensitive data exposure or data leak. Okay, so that is the main difference between HTTP and HTTPS as well. So HTTPS is secure web communication. It will use SLTLS certificates. It will provide encryption, authenticity, integrity, non-reputation, and confidentiality. On the other hand, HTTP will not provide all these. So that is the main difference between HTTP versus HTTPS. Okay. Now, so whenever you are accessing any website, how this particular backend process will work. So as per existing discussion, whenever you are accessing any website, what is the backend process we discussed? Already existing couple of topics we discussed. What is the backend process? If you're accessing any website or application, what is the backend process?
DNS processor.
DNS process is one process. Second one, only
Connect
DNS
site
process. Second one,
ACP.
OSI reference model.
Yes.
Yeah, OSI reference model. OSI reference model, it will provide communication between end user to server or end user to website or end user to client or end user to database and so on. So whenever you are accessing any website, so backend process are 3 ways we can explain. One is OSI reference model. Second one is DNS process. Third one is I am going to explain now. Third process is called as SSL, TLS, mutual authentication, or MTLS, mutual TLS authentication. SLTLS mutual authentication, or MTLS mutual TLS authentication mechanism. How it will work? For this one, what I will do, I will draw one of the diagram. So this is example, you can consider client. Nothing but client means you, me, and everyone. So second one is example, maybe consider server. Example, I can say SBI Bank. So SBI Bank, where it will host? SBIbank.com, where it will host? SBI Bank, where it will host? On top of On top of which server? Any application or website where we will host on top of which server? I'm asking you only any website or application, which server we can host? We can deploy otherwise. App server or web server? Hello?
App server, sir.
Yeah. Application server or web server, we can host it. Okay. Now you are accessing sbibank.com either to apply personal loan or home loan or fixed deposit or car loan, or maybe you want to transfer money. In that scenario, what is the backend process? So in the first step, what will you do? If you want to access sbibank.com, I will go to web browser and I will give double SBI Bank here. Then SBI Bank will open and I'll click on State Bank of India. So once I am clicking on this particular website, now how this process will work? That's what I'm explaining now. Are you getting what I'm saying?
Yes, sir.
Yeah. Now, so first thing is what I given. I initiated the connection in the web browser. So user or client will initiate the connection of SBI website or application.
Yes.
Now what our SBI Bank server will do? So here client, how many keys he will maintain? How many keys client will maintain? One key or two keys? Two keys. No, every system or every server maintain two keys. One is public and second one is
Private.
private. What about server? How many keys it will maintain? How many keys it will maintain?
2 keys, sir.
Yeah, public and private. Now, once you are initiating the connection, what SBI Bank will do? It will send public key. So, public key will be sent it by will send it server. Why it will not send private key server? Why it will send public key only? Private key is a confidential one. Confidential information we can't share with others, right? So that is the reason public is a shareable one. So that's why server will send public key to us. Okay. Now, whenever if you want to discuss about SSL TLS mutual authentication, so we should understand about two topics here. What is first one? So symmetric cryptography or symmetric keys. Symmetric keys. Second one is asymmetric cryptography or asymmetric keys. So symmetric keys why we can use for data transfer. Asymmetric keys why we can use for key exchange. Which key exchange? And public and private. So symmetric keys can be used for data transfer and asymmetric keys can be used for key exchange. Now in the hybrid cryptography, we can use combination of both these two, symmetric versus asymmetric, both we can use these two. Now public key will send it by server. It's a key exchange. Key is exchanging server. Now third step, what end user or client will do, whatever symmetric keys sent by symmetric client will do, client will use symmetric keys for data transfer. Okay, that is third step. Fourth step, whatever public key is sent in the second step, using that key, end user will encrypt the data. What is encryption? What is encryption? Providing a key or password to plain text data. In simple words, providing a key or password to plain text data is called as encryption. Now, whatever public key sent it by the server, using that public key, so what end user will do? End user will encrypt the data and he will send it. So whatever public key sent it by server, end user will use that key and he will encrypt the data and send it to server. Nothing but SBI Bank. Now, in such a way, what will happen? Encryption is formed or not? Encryption is formed or not?
Yes, sir.
Yes, sir.
Encrypted channel is formed in between. Encrypted channel in between client and backend web server or website. Now, how server will see and how it will see whatever the data it is sent it by the respective end user, how it will see it? It has to decrypt, right? So now I encrypted. If you want to see my data, you need key or not?
E.
Yes, sir.
Yeah.
Yes,
So
sir.
server has a private key or
Private
not?
key, sir.
Yes. Server has a private key. Yeah. Server has its own private key. Using that key, it will decrypt the data, whatever end user sent. And finally, it will respond back appropriately. So this is overall how the TLS or virtual TLS authentication mechanism will happen. In between client and server, keys will be exchanged and negotiations will happen. Okay. Now data meaning here, example, I'm clicking on the login button, personal login button. Now here I'm entering my respective username and password. This is called symmetric keys now. Okay. So whatever data example I'm entering, example maybe consider 23780, something like that. This is my username, example, and password. And after that, I have to enter the captcha and login button. So for this one, which one it will be symmetric or asymmetric keys? This is data or not?
Data, sir.
So for data, which one it will symmetric or asymmetric?
Asymmetric.
Symmetric. Symmetric. That's what I said. Symmetric is for data transfer. Asymmetric is for key exchange.
Yes,
Yeah, whatever data we are entering, that is part of symmetric keys. And so whatever keys are exchanged, whatever web browser communication is happening through my web browser to the respective backend server, that is key exchange. It is asymmetric keys. In such a way, communication channel will form. Now, in this entire process, we have one of the drawback is existing or some of the issue is existing. What is the drawback or issue or disadvantage? Second one. Second one is some of the issue is existing. What is that one? Note I'm putting. Note. In the second step, we have some drawback or disadvantage or issue or problem existing. That problem is, what is the problem? We don't know who is sending public key. Whether SBI Bank is sending or on behalf of SBI Bank, any cross-site scripting attack, server-side request forgery, or maybe client-side request forgery, or man in the middle attack, or session hijacking attack will happen. Whenever I'm initiating connection, www.s.com, maybe in between me and sbibank.com, one of the person will come and he will take our session. Okay. So how can you show that whether really server is responded back or someone is responded back on behalf of this server? Okay. So that is the problem here. That problem is we don't know who is sending back public key to end user. Clear? So that is the drawback now. To eliminate this drawback, now what we have to use to eliminate this drawback? or issue, we have to use SSL tier-less certificates. So to eliminate the drawback whether really SBI bank server sent or hacker sent on behalf of the respective server, now we have to use SSL TLS certificates. Now you can see here, how can you identify whether hacker sent or whether it is legitimate server sent based on the domain name. So connection is secure. Now here, click on this one. Now you can see certificate is valid. Okay. So now in this certificate, what is the domain name or common name? What is the domain name or common name?
Google.com.
Google.com. Now it is a fake domain or original domain.
This is original domain.
So
Yeah.
now it's attacker sent or directly Google sent it to me.
Google sent to you.
Yeah. So that is the way how we can identify. If it's a hacker website, we can't identify that one. So, and some test related domain will be there. So that is the way how we can send it. Clear now? Yeah. So for that one, we have to use SLTLS certificates. Now I will move to what is SLTLS certificate. I will explain. Give me some time. Now I'll discuss about integrity. What is integrity? Already we discussed integrity. What is integrity? What is integrity?
Authorized person can add, delete, and update the file.
Yes, correct. Yeah. So trustworthy of the data
Secure.
are only unauthorized users can add or delete
Authorized
or modify the data. What is indirect way? How we can say? Sorry, unauthorized users cannot.
Authorized.
Yeah, authorized cannot add or delete or modify the data. Indirect way, how we can say? Authorized people can add or delete or modify the data. How the data can be modified? What are the ways? How the data can be modified? There are two ways data can be modified. One is knowingly or wantedly. Wantedly, I'm going to, and example, I'm going to example this sheet. I'm giving to everyone admin access to this sheet. So now you are editing or deleting or modifying, data will change or not? Wantedly someone is deleting the Excel sheet. It's a possible or not?
possible sir.
Yeah. So knowingly or wantedly, that is, or intentionally also, this one. Intentionally. What is opposite for knowing? Unknowingly, we don't know, by mistake. Okay. Unknowingly or unintentionally or unwantedly. So without our knowledge, by mistake, by typo error, so data can be modified. So once data can be modified, our integrity will change. Now, integrity is depending on three parameters. Integrity I can write here itself. This adding or deleting and modifying can be depending on three parameters. Integrity depending on three parameters. Those parameters are, first one, hashing. Second one is HMAC,
Digital.
hash message authentication code. Last one is digital signature. So these are all the ways our integrity can be depending on. Now, how this will work, we can see one by one. First, I will explain about hashing, later HMAC, finally digital signature. First one is hashing. So hashing already explained part of our presentation layer when we were discussing about encryption versus decryption. So what is hashing? What is hashing?
Normal blocking EDR.
Yeah, that is
Anti
hash value method. That is hash value method. Whenever any malware category of the attacks will occur, now we have to take the hash value method and we have to block it. But what is the general meaning of the hashing?
Digital representation.
Content.
Yes, digital representation of the file is called as a hashing. So digital representation of the file is called as hashing. Example, I will take one file now. How we can represent digital representation? So now I'm going to virustotal.com. So virustotal.com is a public website. It's an open website or free website. We can verify reputation of the IP address, reputation of the MAC address, reputation of the hash value, reputation of the URL, okay, reputation of the file as well. Okay, now we can go and we can see what is the hashing of the one of the file. What is the digital representation? So now I'm choosing one of the file from my laptop. So example, I will be taking this one of the file, and I'm uploading as a open. Now it is asking confirm upload. I will click on confirm upload. Now it's uploading the file to where? virustotal.com. Now it is verifying malware as well, whether this file has any malware infection or not. It is scanning that file by different vendors. All these are vendors. Antivirus or EDR vendors. All these are antivirus EDR vendors. How many vendors are validated this file now? How many vendors? 60 vendors. So every vendor said that's a clean file. There is no malware infection. Now I'll go to details tab. I'll click on details tab. Now you can see MD5, SHA1, SHA-256, SS deep, TLSH. All these are hashing algorithms. Now what is the hashing is digital representation of the file. What is the digital representation? Either MD5 or SHA1 or SHA2 or SS deep. So this is called digital representation. It's a combination of both characters and
Numbers.
yes. So that is called digital representation. You got it right?
Yes, sir.
So it is a combination of both characters or alphabets and numbers. Now coming back to here, there are three different types of hashing algorithms. First one is, you can see what is the first one? MD5. What is second one? SHA1, SHA-256. SHA-512 also there. MD5. Next one, SHA1. SHA full form, there is no full form. Next one, SHA-2 or SHA-256. SHA-2. So MD5 bit number is, full form is message digest. Bit number is 128 bit. SHA-1 bit size is 160 bit. Length of the bit or data. SHA-2 is 256 or 512. We have other hashing algorithms also, but these three are famous. First two are legacy or outdated. Nothing but old one. We should not use it. What is latest one now? short 256, we have to use this one only. Short 256 or 512. So that is first thing, hashing. So all these parameter is depending on which one? Integrity. So first one is over. What is second one now? HMAC. So second one is HMAC. So hash message authentication code. So what this one will represent now, whenever any end user is accessing any file and is modifying content of the data. So all these are content of the data. Right now I'm accessing this file and I'm modifying the data or updating or deleting. So example, I am deleting this one. So I'm updating or adding. So changing or altering the data. So now that particular message has backend some authenticity and are also code. Who has done this change? Who has done this change now? So RK has done the change or Ramakrishna has done the change. That particular thing can be represented as a hash message authentication code. It will represent about who has done or modify or adding the data, adding the content of the data or body of the data, adding the content of the data or body of the data is called as HMAC. So we can trace it as well. So HMAC can identify the identity of the user and also we can do the tracing as well. So HMAC can identify who has done what and also traceability. So that is called HMAC. Now what is last one? What is last one? Digital signature. Yeah. So digital signature, where we can use, I'm not sure how many people are submitted income tax here. Whenever if you are submitting income tax to the government of India, we have to certify as a digital signature. In the similar way, whenever if you want to download your Aadhaar card, you should be certified digital signature. So it will come as a question mark. That question mark we have to accept the certificate. That certificate will make as the identity of the user. So that one we can represent using digital signature, identity of the user. Okay, that is nothing but integrity basically. So this digital signature depending on SSL/TLS certificates. Once again, digital signature is depending on SSL/TLS certificates and identity of the user, nothing but authenticity. Now, what is the digital signature version? SSL/TLS certificate versions we are using? We are using X.509 version 4. Version of SSL/TLS digital signature. What the version I said? X.509 version 4. So that is the signature of the respective SSL/TLS certificate side. Current version, maybe in future it will change that one. So that is about overall integrity. Based on these three parameters, integrity can be add or delete or modify, and we can identify who has done what also. Okay. So that is about overall integrity part. Now we can discuss about SSL/TLS certificates. So SSL full form is secure socket layer. It's an outdated one. There are three different types of versions we have, like a SSL 1.0, 2.0 and 3.0. On TLS side, we have transport layer security, port number 443. Both SSL and TLS we can use for web browsing purpose. Secure way of web browsing purpose. TLS versions are TLS 1.0, 1.1, 1.2 and 1.3. TLS 1.0 and 1.1 is outdated or legacy. TLS 1.2 and 1.3 we are using right now. These are strong algorithms, strong ciphers, we can use it. Okay. Now these certificates are two different types. One is self-sign, SSL, TLS certificates are two types. One is self-signed. Second one is purchased CA. Nothing but purchasing or buying from third party. Purchasing or buying from third party is called as purchased CA. Self-signed, there is no need to purchase. It's a free of cost. Now, where to generate these certificates and where to deploy? Every organization, it will maintain two different types of applications. One is internal application, second one is external application. So internal applications examples are our salary slips where we are downloading our salary slip like a payroll. Second, time sheet. So we have to update our time sheet to get salary. So that time sheet, that the internal application. Next one is income tax declaration. So that is our internal organization point of view. It will vary from one organization to another organization. Performance appraisal or hike. Okay. All these will fall under so internal related. Whether TCS related HR portal can I access? Whether HR portal of the TCS can I access?
No, sir.
No, sir.
No, I can't access. So can I go and download my salary slip from TCS portal?
Yes.
No. I'm not a TCS employee.
No, sir.
No, I can't. Right? So those applications we can call it internal. Now, what is internet facing applications are? Anybody can access the internet facing. Example, if I want to apply job in tcscareers.com, can I apply or not?
Yes.
Yeah.
Yes.
That is called internet facing. Now you got it, right? Internal means within the organization, whoever employees are existing in the organization or company, those people can access the application is called as internal. Internet means anybody can access, public can be accessed. That is called internet. Okay. So there are two different types of applications. Every organization will use or maintain. Those two are internal applications. Second one is internet. If you want to access the internal applications, which one is a mandatory? If you want to access the internal application, which connectivity is a mandatory? Which one we have to access? Through which one we have to access?
LAN, sir.
LAN, but additional one more thing. That's right, LAN. One more thing, very important one.
CPN,
In an
sir.
internal IP.
VPN. Yeah, with private IP with VPN connectivity. VPN is a mandatory. Without VPN, we can't access. VPN is a part of LAN. It's a part of internal IP. With the internal IP, yes, we have to access VPN. If you want to access internal application, VPN is a mandatory. No, I can go and I can apply now TCS careers exam. This internet facing, anybody can access this website. So for this one, whether I'm using any VPN now, whether I'm using any VPN, no, right?
No,
No,
sir.
sir.
Yeah. So that's why. So internet facing applications, there is no need to access anything, and internal applications compulsory VPN is a mandate. Okay. Now I will explain for internal applications what we have to use self-signed certificate. For internal facing applications, we can use self-signed certificate. So self-signed certificate free of cost. For internet facing applications, we can use purchased CA. Okay. So now I'll provide difference between what is self-signed and what is purchased CA. So I'll put left hand side is differences between self-signed versus purchased CA. So here self-signed or internal apps or tools. Here purchased CA certificate. Purchased CA SL certificate. First thing is self-signed meaning first where we have to generate the self-signed certificate for internal usage. We can generate self-signed certificate in the server or else in the tool. Example, firewall tool or EDR tool or SIM tool or any other tool we can generate directly. That is called self-signed. Example, if I want to show practically, I will go to Portigate demo. I'll click on Portigate demo URL link. It's anybody can access this one. And example demo and demo. I'll click on login button. Login read only. Then under this one, I will go, there are different types of tabs we have. I will go to system. Yeah, system, you can see security existing certificates are existing under this one.
Yes, sir.
Under system, go to certificates. So here I can, okay, so right now it's a demo tool. Okay, so I don't have access to the admin, I cannot generate. Example, if I'm purchasing Portigate firewall for my organization, I no need to purchase CA certificate. What I can do now, I can generate certificate from here itself. I can use it. Are you getting what I'm saying? So now self-signed certificate, either we can generate from the tool, whatever tool we are using, or else in the server. Example, so maybe my HR portal or payslip portal, I'm putting on top of the server. Okay. So now I have to generate the certificate on the server and I can deploy for the server. Who will generate the certificate? Self-signed certificate. Who will generate self-signed certificate? Server admin team. Server admin guy. Because we have to generate this whatever application, wherever we are hosting the application. So that particular place, we have to put the self-signed certificate for internal application side. So we have to generate the certificate on the server side. So who will generate the certificate? Who will take care of server now? Server admin. If it's a Windows guy. If it's a Linux guy, he will provide the respective admin access, right? So self-signed certificate where we can generate either in the tool or else in the server. Self-signed certificate, sorry. First point, self-signed certificate can be generated in the tool, whatever tool we are using, like a security tool or DevOps tool or SecOps tool or machine learning tool, every tool, not only from security point of view. I'm giving example is security. So any tool whatever we are using or server where the application is hosted. So that is on the self-signed side. Then what about purchased, where we have to purchase this one from third party? Purchase certificate we have to purchase from certificate authority. That is but CA. This also entire question. Where you will purchase the certificate? What is the answer? Certificate authority. CA. Example vendors are there. Where we have to purchase. Example vendors are. First one is Symantec, Komodo, GoDaddy, Google. Next one is RHLIDM, VeriSign. There are so many, but these are popular. PKI. These are all the very popular third-party vendors we can purchase from the certificate. After purchasing, who will deploy this certificate on the server where the application is hosted? Who will deploy? Whether you have to deploy or someone else will deploy. Security will deploy or someone else will deploy. Either server team or application development team. Either server team or application development team. What is our role? What is our role is whatever certificate we purchased, the certificate it is using weak hashing algorithms or strong hashing algorithms. So where can we see that one? Example, this one. In case if it is RC4, can we raise a issue or not instead of RSA?
Yes.
Yes, it's a
Yes,
weak
sir.
cipher. That is our role. Certificate deployment installation will be done by either server admin team or application development team or application deployment team. What is our role after purchasing the certificate? What is the ciphers we are using, whether it's a strong or weak? That validation and auditing part has to done by our side. Clear or not? Second one, we have to verify one more thing also from security point of view. When the certificate is going to expire, that renewal part as well, because it's a part of security. So this one is expiring, example, January 15th, 2024. Prior to that one itself, now we have to place an order with these vendors. So, and we have to provide, we have to purchase the certificate. Now we have to inform the server team to deploy this certificate. Okay, now they will deploy it. So what is the security role here? When the certificate is going to expire, that renewal part. Second one is, what are the hashing algorithms and ciphers we are using? So these two validation has to done by our team, security team. And who will take care of the deployment and installation of the certificate? Either server administration team or application deployment team. It's clear or not?
Yes, sir.
Yeah. So second one is, one more thing here for internal application. So one certificate cost will be approximate $200 to $300. It's very expensive. Now you can go and you can see example. I am opening Google. Under this Google, how many websites we have? Google account, Google search, Google Maps, YouTube, Google Play Store, Google News, Google Gmail, Google Meet, Google Chat, Google Contacts, Drive, Calendar. There are so many subdomains. For all these domains, if you want to purchase the certificate, it's a very expensive solution or not? Every domain we have to purchase one certificate. Google Meet one certificate, Gmail is one certificate, Google Drive is one certificate, Google Chart is one certificate, Google Calendar is certificate. All these are applications or websites. And these publicly facing websites and internal applications, we can use so many organization level. Example, in your organization level, if you are using 2000 applications, both internal and external, so 2000 into each and every certificate cost how much? I said, example, $200 you can consider. Now 2000 into 200, how much it will come? 2000 into 200, 4 lakh.
4 lakh.
Yeah, 400K USD dollars. That is nothing but almost it is equivalent to 3.2 crores Indian rupees. It's very expensive. For generating the certificates and deploying the certificates itself, 3.2 crores. Why we have to spend for 2000 applications? That is the reason. So for internal applications, we can use self-signed. It's a free of cost. We can generate on the server. For external applications, we can use on the purchasing from third-party vendor. It's clear now. To reduce the cost, to mitigate the cost, for self-signed, we can use for internal application. For internet-facing applications, we can use purchased CA. Is it clear now? Clear or not?
Yes,
Yes,
sir.
sir.
If we have the money, yes, you can use for internal applications also. If we have money, yes, we can use it. Okay. For internal applications, we can use self-sign certificate. Why? Because it is not exposed to public. Second one, for internet or external facing websites, we have to purchase certificate from certificate authority. That's nothing but CA. Clear now? So this is the way how we can purchase the certificates, and this is the overall concept for the certificate side. Now note also I will write what is our role and what is, okay, so application development team and also server deployment team. Note, as a security analyst or engineer, our role or duty is verifying the hashing algorithms, whether it is weak or strong, and also a renewal of the certificate. Whenever it is going to expire. That is our role. Now, what is the who will deploy the certificates? Certificate will be generated and deployed by server administration team or application
Deployment.
team. So that is about overall certificates and cryptography. So in the overall topic, in the entire overall cryptography, so which one is very, very important for us? So what is the difference between symmetric and asymmetric? Symmetric versus asymmetric, and also cryptography algorithms, examples, and also what is mutual TLS authentication mechanism. So these are very, very important topics from the interview point of view. One is what is symmetric cryptography, what is asymmetric cryptography, differences between symmetric and asymmetric, and also examples of the symmetric cryptography, examples of asymmetric cryptography, and finally SSL TLS mutual authentication. Certificate side, we cannot expect that much. Integrity and certificate side. Okay, clear? Yeah. So that's all for today. In the tomorrow class, what I will do, tomorrow evening I will take. Okay.
Okay, sir.
So tomorrow evening I will take the class because of the elections. So maybe around 6 or 6:30, something like that, I will take the class.
Okay,
Okay.
sir.
Okay, sir.
Yeah. One more thing. I will share one more thing. Yeah. 1 second. Yeah. You asked, right, roles and responsibilities. I uploaded already roles and responsibilities. I'm not sure how many people has gone through this one. Vulnerability management. So far, we completed this vacancy related topics. Second one is EDR. So EDR is not completed yet. I am going to. DLP also I did not complete yet. I'm going to. Okay, so please go through this one also. And yesterday video already uploaded. Okay, and you have mock interviews on Monday. Couple of people did not attend wantedly. Couple of people are already attended. Okay, so that's all for today, guys. Any questions do you have? Any
No,
questions do you have?
No, sir.
sir, in the YouTube